Okay, so last section we're going to look at is 4.3, and it's on solving equations, maybe a little with inequalities. We'll probably use the calculator for that. But they're going to be equations with fractions, okay, rational functions. Okay. So as I said, we're going to do most of it algebraically. We might use the graphing calculator a little bit, but you're not going to have to sketch anything by hand. So, first word problem we're going to do, we need this formula. Distance equals rate times time. D is distance, R is your speed, and T is the time. That's all you need for example 1, okay, as far as formulas. Okay. So, let's just read through the problem and then see if we can figure it out. So it says that Sue drove 30 miles from her house to a train station. She got on a train, and the train brought her the rest of the way to her destination. Okay. Altogether, she traveled 120 miles. We don't know how fast the train went. We don't know how fast she drove. All we know is that the train, on average, was 20 miles an hour faster than her car. So, we're going to figure out a couple things. We're going to find an expression. We'll call the name of our function t for the time it takes for her to complete the trip. And the variable that I want you to use is x, and that will represent the speed of the car. Now, we could say x represents the speed of the train. We could do it that way too. But I want x to be the speed of the car. Right, so this is a problem that when we set it up, it's going to be a rational equation. Another type of problem that would be a rational equation, like very simple to understand, let's say you had a pool and there were 2 drains in it, and you wanted to know how fast the pool would drain if you opened both at the same time. Like, you know how fast it would work if you just opened the first drain by itself. And if you know how fast it would work with the second drain, you can figure out how fast it would work with the 2 together. It's not quite as simple as you would think, but that's another kind of problem we could do. I don't think we will, but we could. All right. So first thing I would do here is just try to organize everything into distance equals rate times time. Okay, we're gonna use that formula. And we want to kind of come up with an equation. So, total travel time. What's the total travel time of this trip? How do you figure it out? Just kind of like big picture. I don't want any numbers. I just want to know, okay, I want to know the total travel time. It's a couple things. Yeah?
Well, it said it in the problem.
It gave me the total travel distance. But it didn't say she traveled for like 6 hours.
I thought it said that she traveled for 120 minutes, or is that 120 miles? Okay.
Miles. Yeah. Yeah.
You need to know how long she spent in the car and how long she spent on the train.
Yeah. So the time in the car plus the time on the train. I always think it's weird how sometimes you use the word in or on. Like, I wouldn't say time on the car unless she was like riding on the roof. But I would say time in the car. Like, that makes sense. How much time was she in the car?
Yeah, but you ride on the bus.
Yeah, you drive.
Yeah.
You ride on the bus, but you ride in a car.
But you're also in the train, so you have the time in the train. You could say that. That kind of makes sense. How long were you in the train? Time in the train. But you'd never say time on the car. Even though you're inside a train, just like you're inside a car.
Yeah, but you never say time in the bus. Like, this is so weird. You're right, it's really weird. Like, a car and a bus are like nearly the same thing, but...
Oh, it's not really.
That's why you ride a bus.
Mine was a lot.
Alright, so we want to figure out the time in the car. Okay, so let's start with that. Off to the side, I'm just going to take my formula, distance equals rate times time, and solve it for time. Okay, I'm going to have time plus time. Okay. how would you solve this formula for time? Divide by r. So you take distance divided by r and you get time. So this is all, the stuff in the left is all for the car. What's the distance she traveled in the car? 30. Over. And now we need the rate that she traveled in the car.
That's x.
X represents the speed of the car. So they already told me what to use. Now I need to do the same thing for the train. Distance in the train divided by rate of the train. What's the distance she traveled on the train?
90.
It's going to be 90 because the total was 120. And what's the speed of the train?
X plus 20.
X plus 20. So there is a function that will calculate the time it takes to complete this trip based on how fast you go in the car. So all you got to do is plug in X, solve it, and then you'll know. For this, that's all they wanted. Any questions on that equation? Now, we've got two separate fractions. For some things, that's fine. Like if we wanted to find vertical asymptotes, 0 and negative 20, we could do that. If you wanted an end behavior model, you'd want to put those together with a common denominator. So depending on what they ask us to do, we may have to put those together. We'll see what happens. Okay, so they want us to find asymptotes, zeros, EBM, and a complete graph. You're doing it on the calculator. Okay. All right, let's start with the vertical asymptotes. I think I just said those. But what are my vertical asymptotes here? 0 and negative 20. Now, I'm not saying that negative 20 makes sense, right? Because this is a word problem about an x is the speed of a car. So negative 20 doesn't make sense. Is it still a vertical asymptote of this algebra equation? Yeah. It just doesn't make sense in the word problem. 0 makes sense because as you approach 0 with your speed, your time approaches infinity. The slower and slower and slower you drive, the longer and longer and longer it's going to take, right? It's like if you traveled 0.01 miles an hour, 30 divided by 0.01, that's huge. Right? It's going to be a very, very huge number. All right. So vertical asymptotes. Let's see. The zeros. All right. Well, so the 0 is a value you can plug in for x and get 0 for y. Could that happen here?
X equals 0.
Well, x equals 0 is an asymptote. But let's combine this into one fraction, then I'll ask that question again. What's the common denominator here? X times x plus 20. Yeah, you could make it x squared plus 20x. That's fine too. What's the first denominator missing to make it the common one? So you're going to multiply top and bottom. X plus 20. X plus 20. And what's the second one missing? X and x. Okay, I already did the bottom. Okay, so I've got that. In the top, I'm going to have 30 times x plus 90x.
20x plus 20.
20x plus 600. Okay.
That's a big number.
Wait, can you say that again?
How did I get 120x?
Yeah.
30x
Oh, plus 90.
plus 90x. Now I think the question is easier. Could the numerator ever be 0? Sure. So that's how we're going to find the zeros. It's a value you plug in for x and get 0 for y. Well, the only way a fraction can ever equal 0 is if the top is 0. So let's see what we get. Yep. If you minus 600, yeah, it is going to be -5. Again, does it make sense in this problem? Probably not. -5 is speed. That doesn't make sense. But it is the 0. It's also the x-intercept. Okay, we've talked about that a lot of times. All right, what else? We've got the vertical asymptote. Let's do the EBM. EBM, it's a lot easier to look at if you combine it all together. What's the highest degree term in the top?
1.
What is the term of degree 1?
120x.
And what's the term with the highest degree in the bottom?
X squared.
You'd have to FOIL it out, but x squared. And what does that give me?
120 divided by x.
120 over x. Okay, so there is your EBM. We could now do the horizontal asymptote.
0.
Yep. Let x approach infinity in your EBM. Y equals 0. So we get the horizontal, the vertical, the EBM, the 0. Is that everything? Yep. So now let's find a complete graph. Now, that's a little vague. Do they want a complete graph of that equation or the word problem? Word problem, I would say set your x min to 0. Okay, I'm going to do a complete graph of the word problem. Okay, so I'm going to eliminate things that wouldn't make sense. Okay. Maybe they don't want me to do that. I'm not sure. Let's say 0. X max is speed, so there is no upper limit except for the speed that the train can go. So let's say it goes up to 100 miles an hour. Y min, well, that's time. Time would never be negative. And Y max, it's how long the trip takes. I'll just say it takes 10 hours, and if I need to go higher, I can go higher. Let's type it in. I'm going to type it in the way it was originally. So it was 30 divided by x plus 90 over x plus 20. So let's do it this way. 90 divided by x plus 20. I don't know if you could get away without that extra set of parentheses, maybe. But if you do it that way, you're safe. Okay, let's hit graph. So notice what's happening. That's the speed of that's the time of my trip. The time, as you go faster, is getting lower and lower. But the time will never reach what? 0. You always have to travel some distance, and you can't travel instantly. So even if you're going 1,000 miles an hour, it still is going to take a little bit of time to go 120 miles. Okay? So that's a complete graph of the word problem. And that's what you would write down for your window. X min, X max, Y min, Y max. Now, you want a complete graph of this whole thing? Well, then I got to go all the way to -30 maybe on the X. And then I could see my vertical asymptote. All right, so Sue has 2 hours to complete the trip. Find the speed she must travel by car. Do it algebraically and graphically. Let's just write down our formula. T of x is it 30 over x plus 90 over x plus 20?
Yep.
Yeah.
And I think to do this, it's actually going to be easier to put it back together. So what was it, 120x plus 600 over x squared plus 20x? What we had? Okay, so how would I solve for x?
T of x equal to.
Yeah, make t of x, put in a 2. 2 equals 120x plus 600 divided by x squared plus 20x. What would be my next step?
Multiply
Multiply by what?
the denominator. The x squared plus 20x and then multiply that times the 2.
Yeah, multiply that on each side, or if you like to think of things as proportions, just think of it as a proportion and cross multiply, which is going to do exactly the same thing Pat just said. Multiply each side by x squared plus 20x. So 2x squared plus 40x equals 120x plus 600. Now, hopefully that's not looking too bad now. What kind of equation do I basically have there? It's a quadratic. Whenever you solve a quadratic, we like to always get it equal to, let's get it equal to 0. So 2x squared minus the 120. What's 40 minus 120? Negative 80. Minus 600. Okay. What could I do to make those numbers? I could make everything a little smaller by dividing it by what? 2. It doesn't really help a lot. 2 numbers that multiply to give me 300 and add to give me 40. 30 and 10. Let's see if that factors. I don't think it's going to factor because your signs have to be plus and minus. If I had this, then I could do x minus 10, x minus 30. And that would work. But because it's minus, it's not going to work. So, how am I going to get x then if I can't factor? Quadratic formula. Okay. So negative b plus or minus, what's 40 squared?
1,000 squared.
Minus 4ac all over 2a. All right, I've got 4 times 1 times negative 300. That's negative 1,200. What's 1,600 minus negative 1,200? 2,800. And the square root of 2,800 is not a nice number. That's why we couldn't factor it. Okay, let's see what we get. Oops. So 40 plus the square root of 2,800 gives me 92.91, and then divide by 2. So we just solved for x, which was the speed of the car, 46.5 miles an hour. Now, technically that's plus or minus. I didn't bother with the minus. If I look back at my calculator, I know the square root of 2,800 is about 52. Right? I'm just looking, 40 plus 52 is 92. So why don't I do 40 minus the square root of 2,800?
Come out negative.
It's going to come out negative. It's going to be 40 minus 52, roughly. That's a negative number. Can't have negative speed. Okay. So that's how you solve it algebraically. How would I do it graphically? What would I have to do to solve using that graph?
You could just trace.
You could graph the equation and like the quadratic equation.
Okay, let's say you don't even have to do anything like as a quadratic. Let's say you skip all the algebra stuff. You've already got this in the calculator. This is in Y1. Yeah.
You just use trace and then hit 2, right?
Well, trace isn't going to give you it exact. I want it as exact as you can. Trace, you may be tracing and all of a sudden it skips where you want to go. Because trace only moves in such like increments. Yeah?
So if you put a line at 2,
All right.
and then second cal intersect.
Yep. Put a line at 2, and it should be 46.5 miles an hour. Let's see. Intersect. And we get exactly the same thing.
Isn't that like way easy?
What's that?
Isn't that way easy?
Yeah.
Of course. Technology always makes things. Well, I shouldn't say it always makes things easier. But remember, certain things the calculator can't do, like if there's imaginary answers to problems, the calculator can't do it. So we can't always use the calculator to do everything. But it is a good way to check it. And when you get to calculus, I don't think Mr. Babel allows graphing calculators.
Really?
What? Oh, excuse me.
We can talk to Mr.
I'm not taking it. Oh, I know, my mom.
And the reason why is because under second calc, there's options 6 and 7, which we don't deal with, but 6 is a derivative and 7 is an integral. So if the calculator can do all your derivatives and integrals, then he doesn't know if you've actually learned anything. So he probably won't let you use a graphing calculator. He'd probably let you use a regular calculator because you might have to do decimals and like square root of like big numbers and stuff. He doesn't care if you can probably do that by hand, but derivatives and integrals, that's what the whole thing's about. So, but even that, I mean, it's not like calculus is just that. So there's still a lot of things that the calculator can't do that he's going to have you do. But that's a big part of stuff. So, okay. Any questions on how we got 46.5? Either way. Okay. So, in that example, we did something that we have to be careful about. We multiplied both sides by something with a variable. Okay? If you remember, we made it like a proportion. We multiplied both sides by x squared plus 20x. Now, we've got to be careful because that can create basically extra answers in the problem. Okay? Whenever you multiply by a variable, you can get an answer that shouldn't be there. Right? And we got to be careful. That's called an extraneous solution. There's no way to avoid it. You just have to check your answer and make sure that whatever you found actually works. Okay? So here's an example.
Okay.
X equals 2. What's the answer to that equation? 2. Okay. Is there any other answer for x there?
No.
No. X is 2. So just remember that. I'm going to do the same thing on both sides. I'm going to multiply both sides by x. I have x squared equals 2x. Okay, so far. Did I do the same thing on both sides?
Yes.
Now it's a quadratic, so I'm going to bring everything to one side. X squared minus 2x equals 0. And I'm going to solve it. I'm going to factor what's on the left. Factor out the x. Remember, originally we had an answer of 2. Is 2 still an answer?
Yes.
Yeah, 2 is still an answer. But what else is an answer here now? 0. I did the same thing on both sides, but I created this extra answer of 0. Does 0 work in the original? No. Because I multiplied both sides by a variable, I created an extra answer. So I have to check it and make sure it works. Now we're going to be doing rational, so it's not as simple as that, but it's the same idea. Okay?
So you check it by like graphing it?
You check it by plugging it back
Not
in.
really the answer.
Okay?
Fun times.
Just like you would check your answer in Algebra 1. Take it, plug it back in, and see if it works. Generally, and that, I'm not going to do this. I already showed you guys the one in red up above. A lot of the problems we solve are going to have 2 answers. The things that can happen, out of the 2 answers, they both work. Or, out of the 2, one works, one doesn't. The other thing that can happen is they both don't work. Right? So when you solve and get the 2 answers, you have to check them. It could be any one of those 3 cases. But it'll always be one of those 3. There's no other options. They both work, they both don't work. Or one of them works, the other one doesn't.
So what if they both work then?
Then when you're writing your answer, you would write x equals, and you'd show them both. If only one of them works, you could write x equals 2, x equals 3, and then say, nope, this one is extraneous. So you could just show me that you found it, but it didn't work. And if they both didn't work, you could just cross them both out. So, when we have a problem like this, the way we're going to solve it, we're not going to be finding a common denominator. We're going to try to wipe the denominator right out. Okay, by multiplying by whatever we need to make that happen. What do you need to multiply by? The LCD. It's kind of like if you had x over 2 plus 3 over 4 equals 12. I'm just going to do something like that. And you don't want to deal with fractions. Well, if you multiply everything by 4, which is the LCD, you'll get rid of all your fractions. This number is going to get a lot bigger. But at least if you multiply by 4, you're going to cancel out the fraction there and there. What we're going to do right here. Okay, we're going to multiply everything by the LCD to cancel out my fractions. And we're usually going to end up with a quadratic. That's why I said you're going to have 2 solutions. All right. Graphically, I don't think I'm going to go through how to do it graphically. You guys should already know how to do it graphically. Put that in y1, put that in y2, and then see where they what. Just see where they cross. Right? You may have to zoom out. You got to make sure you're careful with your parentheses when you type it in. But algebraically is something we haven't done yet. So I'm just going to do it that way.
So you can check your answer every time by graphing it, really.
Yep. But if the problem says to solve algebraically, and all I see is x equals 5, x equals 6, and there's no work for how you got those answers, then you wouldn't get credit for it.
But could we still do the work and then check it?
Mm-hmm. Yep. Okay, so if you look at these factors, a lot of times what I do, so it doesn't get too bad, if you take x minus 1 and x minus 3 and multiply them together, you actually get that right there. So this is not another factor. It's not a different factor. It's just these two right here. Okay. So the LCD is the product of all the different factors in your problem. And remember, this is just this. Those are not different factors from the other two. Okay? So can somebody name to me all the different factors in the denominator? X minus 1, x minus 3. So that's what you need to multiply everything by. X minus 1, x minus 3. X minus 1, x minus 3. X minus 1, x minus 3. Okay, a lot of distributive property here. But cancel out what you can first. What's going to cancel in the first fraction? The x minus 1 is gone. What's going to cancel in the second one? X minus 3. What's going to cancel in the third one? The whole denominator. Because you had an x minus 1, x minus 3 in the bottom, and now you have it in the top. So right-hand side, very simple, 2. So if you want, we can put that right now. Now, the rest of it, just do your distributive. What's 2x times x? And 2x times negative 3? Yep. That's mostly where people mess up. They'll write like 2x squared minus 3. They don't distribute. Here is another place they mess up. This is what you have to distribute. That plus sign goes with the number. Is it really a big deal? No, because it's a plus sign. But when do you think it would be a big deal?
It was a negative.
Yeah, if it was a negative, it's negative 1 being distributed. Okay. So when you distribute a 1, it doesn't change anything. Just x minus 1. And now we've got a nice simple quadratic without any fractions at all. Okay. So when we have the quadratic, we always get it equal to 0. 2x squared, what do you get when you combine your x's? Minus 3 equals 0. We can try to factor it. Let's see if we can. If we can't, we'll use quadratic formula. So, 2x and x. Two numbers that multiply to give me 3.
So 2x plus 1 is x minus 3.
Okay, let's try it. That's good.
It works.
That's 2x squared. Minus 6 plus 1 is minus 5. And yep, perfect. What would make x 0 in the first, what would make the first factor 0? negative half. And the second factor?
3.
Okay. Now we just have to check and see, do they both work? Do they both not work? And usually what happens when they don't work is it would cause you to divide by 0. So let's see. Let's check 3 first.
Can't do it.
You can't plug 3 into the original problem because you'd have 1 divided by 0. Doesn't work. So 3 is extraneous. Let's check negative 1/2. Would negative 1/2 cause you to divide by 0 here?
No.
Nope. Over here?
No.
Nope. Then it should work. I'm not going to do it all out, but as long as we did the work right, which I think we did, it should work. Okay, so this one answer worked. Questions on that one? All right. Let me just see what we have. Rational. All right, I guess we'll try another one of these. Now, you might look and be like, oh geez, it looks different. Well, it looks a little different because they already got it equal to 0 for you. So they actually saved you a step. When this turns out to be a quadratic, you would have had to bring something to the other side anyway. Let's factor the numerator here just to make sure that there's no different factors here. Okay. How does that factor the denominator? X. So how many different factors are in the denominators? 2 multiplied by those 2 factors everywhere. So x plus 2. All right. So we're going to do x plus 2, x plus 2, x plus 2. Okay, at least if you remember to do that, you'll get some points because you knew what to multiply by. What cancels out in the first one?
X.
All right, second one? And the third one? Everything. Okay. So I'm going to have plus 6. The first one I need to FOIL. It's going to give me x squared plus 2x minus 3x minus x, negative 3 times 2, plus 6. Actually, that's, if that was a minus and a plus 6, that would have been nice. Because if you can get the constant to disappear in a quadratic, it makes it very easy to solve. But
Isn't it?
that is minus. Yeah, I knew that. Thank you. So actually, yeah, that's good. So and what about 3 times x? 3x. Jeez, the second mistake I've ever made. So I think we're good. Minus 6 plus 6, that's great. Minus x plus 3x. So x squared plus 2x equals 0. Factor out the x. What are the 2 values here that would make that equal to 0? Now, what do we have to do with them? Plug them back in. Can you plug 0 into the original?
No.
Can you plug negative 2?
No.
No, this problem has no solution.
So when you graph that, would it just like not touch?
Correct. This would never hit 0, ever. Just would never hit it. No. So if you were to try to graph this, you couldn't solve it. It wouldn't work. Okay, any question on that one? Okay, so we did one where they both don't work, one where you get one works. The other option is they both work.
Okay.
Okay, so going back to the problem we had. At what rate could Sue travel to make sure the total time for her trip is less than 2.5 hours? So now we're kind of switching gear from an equation to an inequality. Okay.
46.5.
So we want the total time for her trip to be guaranteed to be what? 2.5. So all we have to do is look up the formula for the total time of the trip and plug that in right there. Can someone remind me what it was? 30 over x. So we want the total time to be less than 2.5. Now, we're not going to solve it algebraically. Solving algebraically gets a little tricky because what rule comes up when you solve inequalities that doesn't come up with equations? You might have to flip the sign, right? You flip the sign if you do what? Multiply or divide by a negative. If I multiply everything by x plus 20, well, I don't know what x is. What if x is a negative?
Well, it can't be though, because it's.
Right, in the word problem, it can't be. But let's just say this wasn't a word problem, and I just said solve.
You would just have one where you flip in, one where you don't.
Yeah, you kind of have to break it into cases and be like, well, if x was negative, this would be the solution. If x is positive, this would be the solution. But they just said to do it graphically, so we don't have to worry. So hopefully I still have that typed in. Yep. And I'm going to put a line at 2.5. So there's my trip time. Okay, we're going to see the horizontal at 2.5. What am I going to do now? Find where they intersect. Okay, so we've got the intersection. Now we got to be careful how we write the answer. Let me just make it a little bigger so people can see the number. Okay. So 34.9. So remember the original question.
It can't be 34.9 because that would be greater than 2.5.
You never figure out how fast you got.
Oh, okay, never mind. Because if you were going slower than that, okay, never mind.
So what rates could she travel at to make sure she gets her trip done in less than 2.5 hours? Right. Anything greater than that speed will guarantee the trip time is less than 2.5.
Speedometer, she's just gonna
That's
adjust it at that point.
That's the minimum speed she can go.
My speedometer starts at 2.
So what speed? And it does say less than. It doesn't say less than or equal to 2.5. So no equals. If she travels at a speed greater than 34.9 miles an hour, she'll be traveling in this blue section. That will guarantee her time is under 2.5.
Oh. It needs to be less than 2.
Yeah, if she's going slower than 34.9, she's going to be in this section. Now her time to do the trip is above 2.5. You don't want it above, they want it less. Okay? Any question on solving that one? Okay. So, this is the last one? Yeah. So last one we're going to look at. Okay, remember, whenever you solve something graphically, make sure you check out things that could be hidden. Hidden could mean something looks really flat and it's not, like yesterday. Hidden could mean it's off the screen. Okay, so make sure you zoom out, zoom in, whatever you got to do to get a good picture of what you're doing. And we're just going to worry about graphically. Okay, that's all we're going to worry about. We're not going to do solving algebraically. So that's what you want to know. Okay, so let's look at this one. So it says solve graphically. Now, we've got two options. We can either leave it like that, or what's the other thing I could do? We do it with quadratics. you could get 0 on one side. So you can either leave it the way it is or move the 15 to the other side. It's going to change whether or not you're finding roots or intersects. Okay? I'm going to leave it the way it is. I'm going to do a y1 and a y2, and I'm going to do intersects. Okay, but if you like roots, you could do it that way. All right. Parentheses, yeah, you want parentheses. So, x to the 4th minus 3x cubed.
You have a plus, it's supposed to be a minus.
Thank you. 2x squared plus 2. And that's supposed to be a minus. There we go. And now divide by x minus 2. Now, this is what kind of equation is this? Because it's a degree 4. It's quartic. How many times could it turn? 3. So, most complicated case is you get a W shape. And you could have a line going right through that W. So we might have a lot of intersections to find. So I say that it could be a W because if you don't see all the turns, you're going to want to zoom out. All right, so I can kind of see like it starts to kind of do something weird in here, but then it just keeps going down. So, did everyone else get a picture that looks like that?
Yeah.
And then 15, can't even see it. So if I set my y max at 15, actually let's even go like 25. I think this problem is going to be, it's almost like a special case. So we've got that. Oh, okay, so no, it's not what I thought. Third time. So at first I was going to say I was going to say no solution. Because I was going to say, well, this graph is never above the red. But it is. So what should I do now? Find those two intersects. So second calc, intersect. Okay, I'm on the blue. If I just keep pressing right, it should eventually jump up to the other part. There we go. The guess does matter. So it's just going to write it down, 2.22. And I need the other one. Just put the guess a little closer, and it should pick up the other one. 2.68. Okay, so now the question is, when are we above the red line? So it's definitely in this section. Not in the little section below, but it's in this section. I know where this section on the right ends. Let's make it bigger. Put this here. What's that point right there?
2.22.
2.22. Okay. So, and did it say equal to? It did. Okay. So, it's going to end at 2.22. Including it. Where does this interval start?
2. Starts at 2.
Starts at 2.
But not including 2.
How did you know it starts at 2? Besides, you could kind of see it in the graph. How did you know that looking at this?
Because if you put x as 2 and the entire thing comes out as 0.
Yeah.
I just stretched an accident.
Did you knock my light bulb?
Sorry. No, it's not in the blood.
No, that's my wife in the
Like
phone.
you knocked over his wife.
Yeah, why do you?
Alright, so this interval starts at 2. Can we include it?
No.
No.
So it has to be.
I put a parenthesis because that's an asymptote. Okay? if you had an asymptote, I would make it very easy to find like that. Okay, because this is already a pretty complicated numerator. So the denominator I would make simple. So now you've got this part right here. How about this part? Where does it start?
2.68.
2.68. Can I include it? Yes, I can.
And then to infinity.
And then to infinity, this part is just going to keep going.
Why wouldn't that part keep, not
Okay, so at first, with a standard window, you didn't see this part up at the top. You've got to zoom out and check it. And then that's it.
Did you put like the U thing?
Yes, thank you. You put a U. Okay. So, homework for tonight is part 1 of the test. Okay, what's that?
Are you gonna hand that out or something?
I'm going to hand that out. The
You
test.
have to come up with it yourself. You have to write your test. It's on Google
Well, that would be easy.
Okay, the test will not be online.
Yeah, kick the Google.
So if you lose it and you come in tomorrow and you say, I don't have part 1, that's okay. I'll give you part 1 again. But you have 39 minutes to do part 1 and part 2. So don't lose part 1.
I'm gonna lose this. It's over.